Hi everyone, I want to share a video on multiple regression analysis using SPSS statistic. Multiple regression is an extension of simple linear regression. It is used when we want to predict the value of a variable based on the value of two or more other variables. The variable we want to predict is called the dependent variable, or sometimes we call it as outcome. We call it as outcome or dependent variable. So here we have the dependent variable of C. The variables we are using to predict the value of the dependent variable are called the independent variables, or sometimes we call it as predictors. So here we have the predictors A and B. Column A represent the predictor of A, column B represent predictor of B, and C is the outcome. So here we have the total of 60 data. Multiple regression analysis using SPSS that we want to show here is to see the ANOVA test. So we want to see the p-values. The second one is collinearity statistic. So we want to determine the parameter of tolerance and also the VIF, variant inflating factor. And lastly is the Durbin-Watson statistics. So these three tests we want to see in our statistic result. So first we need to open the SPSS. So we have this kind of view when we open SPSS software. So here we have the SPSS statistics data editor. So now we need to import our data. So click on File, click on Import Data. So example here, I have the data in Excel. So I just click on Excel. So this is my data. So I select, then I click on Open. Here, read variable names from first row of data. So I take percentage of value that determine data type at 95%. And lastly, also select the ignore hidden rows and column. So these three settings are selected. Then I click on OK. So this is the data that we import from Excel to SPSS statistics data editor. And we need to click on Analysis, then Regression, and click on Linear. And here we have the dependent and independent section. So for dependent, we select our dependent variable, which is C. For independent, A and B. For the method, just select using Enter and click on Statistics. This is linear regression statistics for regression coefficient. Select estimate and confidence intervals. The level at 95%. Model fit. Then I click on R squared. For the collinearity statistics, I select for collinearity diagnostics. For residuals, I select for Durbin-Watson's and click on continue. Click on plots. So we have the y and also x action that we need to fill. So for y, insert y, z r e s i d, and for x, z p r e d. Standardized residual plots. Select for histogram and normal probability plots. Produce all partial plots. Also selected. Then click on continue. And click on OK. So wait for the result to come out. So this is the result. So this is the model summary. So we have the Durbin-Watson here under inside model summary. Then we have the ANOVA. So we have the p-value, very small. Then we have the coefficient table. So here we can check the model for multiple linear regression analysis. So for example, here for coefficient table, so we can see here the p-value for the t-test is very small, quite small. When you bring your mouse to the number, then you can see. So this is the p-value, and this one is the t-value, and this is the coefficient, unstandardized coefficient. So this one is for predictor of A coefficient, and this one is coefficient for predictor of B. And we can see also the p-value in the ANOVA table, which is this table. So the p-value in the ANOVA table indicates that there is a linear relation between dependent variable of C and also predictors of A and B. From the output, the regression equation is given by y equal to negative 7.605 plus x1 with a coefficient of 0.07 plus 5.382 x2. So x1 represented by A and x2 represented by B. The values of VIF that exceeds 10 are often regarded as indicating multicollinearity. In our case, all the value of VIF are below 10. So here we have the value of our data, VIF value, which is 2.408, indicating that there is no multicollinearity. We can interpret the equation of multiple determination of R square. The coefficient of multi-determination is 0.818, R square here, 0.818. Therefore, about 81.8% of the variant independent variable is explained by the independent variable. The regression equation appears to be very useful in making predictions, since the value of R square here, 81.8%, is close to 1. According to the rule, the value of Durbin-Watson statistics range from 0 until 4. Durbin-Watson value, which is less than 1.5 or greater than 2.5, suggests that the autocorrelation may exist in the regression. In our case, the value of Durbin-Watson statistic is 1.8, 1.635. So our value is 1.635, which falls within the acceptable range of 1.5 until 2.5. So it's within the range. So now can put back what we have from the output by using the SPSS for it. So our y is represented by C. So B0 negative 7.605, and for B1 0.007, and then for B2 5.3 at 2. So we just replace what is our x1. Our predictor x1 is represented by A, and also x2 predictor of B. So we just substitute all this result into this general equation that we can have the final outcome for multiple regression analysis. So you can try with your own data and enjoy this video. Thank you.